Yo, 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 Blue, what's up, what's up? Welcome back. Hello, hello. Alright, just copying some tags and stuff. There we go. Alright, I think we're set. Yeah. Okay. Welcome. So Kottefolket, which is my metroidvania game. We're back to this one. So what I did was, between streams here, I actually updated it to 0.16. And it seems to work fine. So I had to change a lot of... yeah, it turned out there was a lot of places I used like random, which now needs IO. But mostly I could do like the kind of the same edit everywhere, so it wasn't really a huge deal, to be honest. And yeah, so let's see. By the way, am I too loud maybe now? I'll lower it a little bit here. I don't know. Anyway, so let's see. Yeah, so one thing that I noticed, well, there was a little bit of issues when I first started it up, so I had to fix some issues. And I think there was some of the issues where I was like, before I didn't really know how to fix. So then I think my motivation went down a little bit from that. But now when I came back, I was like, well, this is an obvious fix for some of these issues. So it turned out I was actually like, sometimes I was iterating through using some kind of iterator from the ECS library. Sound is good. Okay, thank you. Just out. And I was like iterating through entities while in the iteration logic also like removing the thing I was iterating on, basically. So I was like, well, this is an obvious like solution. I have an obvious solution to this. So yeah, some of those issues I've solved. And one thing but I noticed one issue in particular, and I can show you here if I run the game. Also, I need to set up with my controller. I'm not sure if this will work now, if I have to like add this through Bluetooth or whatever. Yeah, I just need to add my controller here. I've had such issues with this controller. Maybe I think it's because it's supposed to be like it's supposed to be used with a switch or something like that, and it's not really. You have to have a special version if it's gonna work on the PC. I don't know. Okay, whatever. I'll just use the keyboard for now. I'll fix that later. All right, so you basically go. Oh shit, you can't see. Hang on. There we go. Do you see everything though? Okay, there we go. So that shouldn't be like that anyway. Yeah, so it seems like most of this stuff works. You can see the transition is kind of lagging a little bit when you transition. I'm not sure why that is. That hasn't happened before. I also would like to see if I can get the tracing program to work. The library to work, ztracy, so I can profile some of this stuff. I can turn on the sound here for this. Oops. Yeah. Hey, thank you. Yeah, hopefully I can start working on this. Continuing to work on this a little bit, because it's been on the shelf for a while. For like, man, when was it? I think it was like, I switched to Runic like, when was that? Man, was it really a year ago? No, that's not correct. I don't remember actually. I'll have to look that up. But here's the issue. So here's a chest, and we open the chest and everything starts lagging. The reason is that the quad tree collision algorithm thing, well, the issue isn't the quad tree itself, I don't think. I was gonna research a little bit on this topic, but it's basically how we're doing collision is that we have a quad tree that is built up every frame from all the things, and it's a quite quick process, so that's not really a huge deal. The deal is, well, I guess we don't really see what the actual cause of this is because we don't have profiling on this, but my guess is that since everything is like in the same kind of area, there's a lot of brute forcing going on. Hello Gopnik, what's up, welcome back. I'm doing fine, thank you very much. How about you? I'm back doing my game here. And if I enable collision boxes, you can see that there's a lot of, there's a lot over here, and this is in one quadrant. So I think that what's happening is basically we get a lot of brute force collision checks going on here. The thing is, like, I do have groups, so these are not supposed to like collide with each other. So they don't really need to check against each, like, their own group. So my idea there, and if I start to pick them up, you can see that the lag ends. So my idea is to have some kind of collision group thing in the quad tree, like incorporated in some way. One idea was to make a quad tree for each group. Well, that means that to find collisions, you would have to go through now multiple quad trees in order to find. So basically, let's say you have items, they're colliding with, let's say ground, for example, and player. Actually, the only thing they need to be checked against. Wait, hang on. Could it be it's not the... Yeah, because I think also what's happening is that the player is also checking where we are colliding. So if the player is like in the same quadrant, I think that would like significantly lower perform, or not significantly. I guess it's only like 30 more checks. It's like 30 gems being spawned. We could also just lower the amount of spawns and set the value higher or something for like that. Like spawning 1 gem. It's just fun to pick up a whole bunch of gems, and I would like to. It's not an insane amount of like gems either. Like you should be able to have 30 things at the same spot without it doing that. So I would like to solve the issue to improve the collision system a little bit. All right. So let's see. So here's the quadrant. So actually it's not really a lot of difference though. If the player's over here or if the player's over there. It's just, I guess it could be like a tiny bit of difference. Oh, there's really not much difference. I think it's just, yeah, it would be great to have the profiling work. I'll take a quick look at Z-Tracy to see if they've updated or. Oh, God damn it. Z-Tracy. Well, they're at 0.15. I mean, we could also try to just clone it and monkey patch it. Is it lagging because of cross checks on jams? Yeah, so the way it works is that we have a quad tree. So I'm kind of this is kind of the quad tree visualization here. It doesn't really show much now because there's there's not much going on in this scene here. But basically, the lines you see are like the. Here you can see, so the green line, it's you can't see the whole thing, but it's actually like a rectangle spanning the whole boundary of the map. And the blue lines, which should be over here. Somewhere here. The blue lines are the next level, the next layer. So basically, the green line spans the whole map, and then you divide. The quad tree works like it's recursive. It goes down like you take the whole map, and then you split it in 4 quadrants. So you have, 4 rectangles that builds up the whole map now, and then each of those also is divided into their own 4 quadrants. And so now, for example, you can see that my collision box is inside this blue quadrant on this side. If I go over here, now I'm on this side, and the red thing is showing here because of the next layer being created because I moved over here. So and that is the quad tree is then used to be able to more quickly find where, like, which candidates you can check against. So basically anything that is outside of the quadrant you're in, you don't need to check against because, yeah, it's outside of your rectangle. So right now, this guy is over here, I'm over here. I don't really need to check against this because I'm over at this rectangle. So we're checking, like, we're going from top down. We're checking the larger rectangles first and then go further down until we reach the end. And so the player only needs to really check against this ground and this ground over here. And all the quadrants on the way there. However, if you have a lot of things on in the same quadrant, and it's not really dividing anymore, then we still do a brute force check at that stage. There's also another thing we could do. Maybe we could do like a sweep check. But it all depends, like... There's also another issue. It's like the items are... So what you also need to do... Let me see if I can get an item here. There. So the quad tree is used both for like the physics simulation, like when we collide into something else. That is where we use like collision groups. So if the player is in a collision group called players or player or whatever, and then that only collides with some other groups. So this is the ground group, so we collide with that group. But that is only for the physics simulation. To actually check against like an item, we call the quad tree to look for collisions, for any collisions, and if any of those, like right now we only get like the ground, and if any of those are items, we pick it up. So there we go. Now we picked it up. But yeah, we would need a profiler to actually figure out what the actual cause of this lag is, because I'm just speculating here. Do we have Z Tracy here? No. It's in here. Oops. Wait, I have it. Oh yeah, this is this stub thing that we made. Okay, I'm gonna try and... I'm pretty sure we updated it. I'm gonna check if there's a special branch or something for this. No. Okay, so what we'll do is I will clone this down. And I will try to... Let's try build. Seems to work. Maybe. It's linking now. So maybe we just need to update to the latest version then. No? Or not? I'm just gonna check. The version is 16, yeah. So... What is this? Libs Tracy. So this is like the, I guess, yeah, the C++ Tracy version here. So this is basically just a very thin layer, I guess. It's like a bindings, except the library is like within the thing. Right. So if we go to build. What the hell is this? What's that error? What the hell? Okay, let's do sig build and we'll just see what the errors are. So we got this one, testing. No, here. Root source file struct testing has no memory ref. All declars recursive. I mean, I wonder if it's just if it's recursive now or. Yeah, I have my own implementation, so I have some kind of limit to, like, if there's like there's a number, like let's say it's 3, like if there's less than 3 or if it's 3 or less bodies left in a quadrant, then it doesn't bother to divide it anymore or something like that. I'll check it out. I just want to get the I want to see if I could get the profiling to work so we can see where the actual cause of the issue is, so we don't have to like speculate and spend a bunch of time. It's good to do that as well, of course, but I just want to see if I can get this working here. Well, this is just for test though, so it's like, who cares? Okay. Wait, is that it? Is there a example here? No. What about test? Okay. Is that really it? I thought it was gonna be way more. Right. So now ztracy is added as a file path here instead for in my local thing here. And so now I want to go to build.zig and I want to get these things back here. Disable the stub that we made and enable the real ztracy. There we go. And I think that should be it. Oops. We'll go back. And let's see. I forgot how to actually enable the options. Do you have to, is it -D? Is that what you have to say? Enable tracer like this? Or is it like this? No? Or like this? Also, I'm not sure because this is like a sub project. Have a try to code and saying, all right, yeah. Yeah, no problem. I'll figure it out. So you can provide these options here, and they will show up as options here somewhere. Yeah, so okay, let's try that. Oh, I see. I think I need to. I'm not sure if I've used this with the game before. Hang on. No, yeah. So what we can do is we can create our own options. Okay, I forgot how to do this. So there we go. And then for ZGE, I think we just pass it here. We just pass it along. How do we like register it as an actual option? Oh, B option. Wait, but that should be. No, if I say help. It is there. Enable. Did I misspell it? Oh. Okay. We got further. So what is the issue now? Undefined symbol, trace emit zone begin. There seems to be some linking issues. Okay, let's try here. Let's try this first. This is like the game engine sort of part. Enable Z-Tracy. Shared is false. Also, this is very weird error here, but I mean we can seem to build this project, so So where is the library compiled and all that? Is it this one? Yeah, seems to be. Okay, yeah. I think they did update this one because I'm pretty sure I did some monkey patching that did not look like this. Because you can also say here link libc instead of this. But I mean, I guess it doesn't matter that much, maybe? I don't know. Okay. Yeah. Install artifact tracing. I don't know, man. Well, it's not here. I don't know, actually. It's like we're missing something that we need to reference or something. It's like it's like my speculation is like, is the bindings wrong? But this project builds, and the test seems to work. What is this stub here? Oh, they already had a stub. Okay. And then we have an implementation. So we have a zone. So yeah, my thought was that maybe this is wrong. Like these names here. Hell is this? Or is it defined like from outside or something? Okay. Oh, wait. Oh, I see. I could have searched like this then. So like... Alright, cool. Good to know. Man, these weird things in C and C++, man. I have no idea what this is. Deco spec. DLL import, export, Tracy exports, Tracy imports. So if we're on Win32, it's doing some weird stuff, and then this is basically nothing here. Okay, whatever. Well, the point is that the thing does exist. The symbol exists. I was just checking if maybe in some cases it wasn't defined or something like that. Hey, Bo Massey. You got a lot going on here. Yeah, I'm just trying to figure out this issue here. It's very local, I would say, to this. I mean, the error message is very local to this specific setup, so I won't be getting any answers like Googling for this. So, okay, so maybe I'll just go through a little bit what's going on. So basically, we're using this ztracy library for profiling Zig program. And it's using another library or program called Tracy, and it's implemented in C++, it seems. And then we're using Zig. This project has like has the whole C++ project in it, and then it also has like Zig bindings to it. And then the idea is that we're just going to use it, and we'll be able to profile it. And I have used it before, and I know that it has worked before, but now after the Zig 0.16 update, there's been some changes, and we had to bring it down and do some upgrades on it so that it would run in here. It seems to be only like the testing thing that was an issue, but so really it's I think it's already been upgraded, but well, for the most part, maybe it's been upgraded against like some dev version of 0.16 or something like that. But now when we try to actually use it, we get an error saying that it can't find a symbol here. And I was trying to figure out why, basically. So just looking at the project a little bit, seeing how it's built up and all that. But my first thought was that, well, maybe something is not linked properly, something is not referenced properly. So I'm not sure what this means, like dep c traces. So we have that as a dependency, and the information about the package is in a file, so which points to our directory, so that should be fine. Okay, we got a root file, we've got some cache stuff. Maybe we'll remove the cache. I don't think I've tried that. I tried it before. It's only these also. It's like begin and end. Those are the only ones. Because we are using... Or maybe that's the only thing we are using, actually. Now that I think about it. Module root, I guess, module raylib. Yeah. Wait, could it be... Are you also using Zig tracing? No. I was thinking like what happens if you have two package, like if you have this module, I think they're separated, like the question is like if you have two things in the same build, two modules in the same build trying to reference another module, but they have different versions. And I think that I don't know if that's an issue, or if it's an issue or not, actually. If I got an error like that, my head would probably explode. Yeah, I feel like my head is starting to ignite a little bit, because I'll be honest, I don't know exactly how to solve it. I can see the symptoms and kind of try to guess my way to a solution. Maybe it could also be something that is just an issue with the compiler. I don't know, because it's not. But it just feels like it should work. Let's see, ztrace options. That's another package then. And here's the ztrace module. Ztrace options. What is that? Okay, that looks sane, I guess. I don't really know about the fibers, but I mean, I guess we could try and enable the fibers as well, but it doesn't seem to be the issue. That just seems to be to change something. Like, this basic case should work. We're just using the most basic functionality of the library right now. Oh, here's like the C module is this one. Okay, cool. We've got win. What is that? Is that memory map? No, I don't know what that is. GDI. Yeah. libc. All right. Oh. What the hell? Wait, what the hell is this? Unable to translate C. Compiler. I mean, it seems to only be some of the things. But still, maybe something goes wrong and it has trouble actually forwarding that problem. and it messes up something else. Unable to translate C. Okay. I wish there was like a test example or something here that would make this easier here. But what we'll do is I'm gonna go over to this and then we'll do that to get the thing. No, here it is. Yeah. This thing here. Except it's in there. Okay, so we've got errors in traces c.h header file. I'm not totally oblivious to C and C++. So let's look at that. So apparently the this is unexpected. Maybe. Wait. 9? Okay. Maybe it was like this expression here. And then over here, notice that there is no such thing as that thing there. Okay, were these also? Tracy. Undefined identifier. Oh, that's a different issue. Okay, so I think all of these. I have low confidence that this will actually do anything, to be honest. But oh, sorry. Whoops. Well, okay, now we can just edit this again. delete the cache and try again. Because it seems to be very compartmentalized. Like it doesn't seem that that error would actually cause the other issues to happen. Okay, and we still... Wait, but this is... No, it might be a different hash now. No, it looks the same. Also, I don't know this new Zig PKG directory, what that actually does. Let's see, did it change the hash now? No, still the same, looks like. I mean, it starts and ends at the same thing, then it usually is the same thing. I guess I'll do this just in case. Strange. It also feels like it should be there. Maybe. Wait, I'm confused here. This defines the actual macro. This, I guess, uses the macro to define a thing. This feels like it should have the... Okay, I don't know. Maybe it's an issue with the compiler translate C or something. I'll just undo this. Actually, I never tried this. I found another project that also kind of does the same thing, except it's like 6 years old. So that does not help. Zig Tracy binding 3 years ago. Okay, I'm gonna check this and see if there are any notes on this one, like upgrade notes. yeah, and I mean it's only for testing, but I'll check if there are any. Let's see. Wait, this does not seem to be the same thing. No, that's not correct. Here it is. I was like, but maybe because sometimes a package is like create a, you have like z-tracy or something like that. But that was not the case here. Okay. Tracy Fibersport. I mean, I guess we can try that. Doesn't feel like it should do anything, to be honest, but. Just 1 second. No. Still same issue. Okay. Module root link library artifact. Okay, I'll try this as well, because I do distinctly remember to actually removing that, because I was thinking like it should do that anyway. If you have the artifact in the module itself, I think it does that with Raylib, for example. You don't have to link the Raylib artifact. So that was. So I actually remove that. So that is actually a very, very good note there. Yeah, because I removed the Raylib artifact. Where is the z-tracy? Here it is. So I guess this would be root module. Is that the correct thing? Yes. And also when we z-tracy module root. Okay, yeah, that is correct. Okay, let's try now. Come on. Okay, we get a different error. Unknown file type. Let's see, the target should. Yeah. We should provide a target here. Pretty sure. It's so crazy how this... I mean, I didn't have to do that before. Okay. There we go. I think it was like linking to Linux or compiling for Linux, and that would cause some issues. Okay, cool. We got it working. Awesome. Okay, so then we should try it out. So if we run this, and I need to enable networking. Yeah. So here you can see this little simulation test here. And if we open up Tracy, I forgot where I had this program now. One second. Or maybe it was called something else. I had a program that you could basically... So what's happening now is that the program starts up a server that you can connect to, and then you have like another program that you can use to look at the thing. I'm pretty sure I have it somewhere, but alright, let me just download this here. Okay, I will copy this, put it somewhere. Okay, actually I do have it here. Okay, I'll just override. There was like a new version anyway. Okay, so then I will open up, I think it's Profiler. And I need to show this to you somehow. There we go. So there's the profiler. Okay, and then it's gonna connect. Let's just try. Okay, it seemed to work. I guess I can move around here a little bit and do some stuff. Okay, if I stop, will it like compile the thing? I'm not seeing any events here. I'm not even sure if we connected to the right thing. Let me check if we have some startup information about which address and stuff. No, nothing at all. Okay. Wait. This looks like things happening here. Why is this not visible in the thing? It should be coming up here. What is this? AI? Oh shit. No wait. Yeah, LLM API. What the hell? I did not expect to see this, to be honest. That's crazy. Okay. Why is nothing showing up? I'm not sure. Like here we can see a whole bunch of stuff. So obviously it found something, and it has counts and time and everything. So why is this not showing up? CPU usage. Like, do we need to add things here, or I don't know. I never had this much trouble before. Strange. Can I like... Oh. Hang on. Find zone. Okay, anyway, maybe we could just use this. Okay, well, we can keep this up. We can do Discord. Yes. Okay. And then I will open up the actual game. And we'll go over to the place. We'll try to, well, yeah. Well, I'll do a test run to see if this works in the game. What's happening? Why is this taking so long? I'm trying to close the program. I think it was like there's like memory leaks or something. Okay, so I will go to game now and try to build this thing as well. Okay, I get the same errors in the game actually. So, wait, that shows the same thing. Okay, that's strange. Because I thought that if it was part of the module, you wouldn't have to add it. Wait, where? Oh, that's part of this thing, right? that is added in like this. Right, I think I made it like this because of we have two different targets. We have like the web GL or web WASM target and then the other target. But I think what I'll do is I will remove this and just add it as an import instead, like this. No, where is it? Here. Oops. Probably do this. So that, yeah, so that maybe now it's like it's like built in a different way. I don't know actually what the difference is. But if it doesn't work now, there's probably no difference, yeah. Yeah. Okay, so then we will have to somehow grab out the artifact from this thing. I mean, we could try this, maybe. No. Available artifact ZGE, okay. I guess we'll try that. Nope. Okay. Do I have to like forward the artifact or something? This feels so weird. It feels like it should be part of the ZGE like module. And when you import it like this, you get the thing that you need. Oh, hang on. Maybe it's... Maybe we need to do that? I don't know. And if that's the case, do we even need to do this now? Okay, we do. But maybe now the other thing works? I don't know. It seems like a basic use case, almost. Like one library happens to have a dependency on this artifact thing. Then you want to use that library. How do you set it up so that we can actually use it without having to do this. Because I was under the impression that you could set it up such that you only have to import the module, and then you get all the dependencies, however they are formed, working as well. You don't have to do some special setup in your own thing to make that work. Maybe wait. This is for the exe. This has nothing to do with what we're importing. Right, this module is what we're concerned about. Right, so this is the ZGE module. This also needs Z-tracing. Or the artifact. I'm not sure if we need to install. Oh, I see. We just do that. Wait. And now maybe we don't need this. Or maybe we do. Is it because we're doing this? Yeah, it should be like main. Okay, I see. It's kind of weird. It's because I think it's because of this, because we're kind of using the program is kind of part of the library, so it's almost we're not really importing the library from the program, the test program here. It's kind of part of the same place. So this is in zge.zig. The main is in, or the program is in main, but the main actually just imports, you know, things from the library directly. It doesn't import the library ZGE, which it should, really. That's how it should be. But okay, so I think that was what I was thinking. Like maybe we don't need to link the library if we import the ZGE module, but we don't actually import the ZGE module. So there you go. Now let's try. Now this should work again. Yes. And then we go back and we try this now. I forgot how we set it up now, but there we go. Hey. So now we've got, where did it go actually? Well, you don't see it here, but wait. This should be, wait, that's the wrong. There we go. Yeah, so we got the game working. And now I'm gonna try and do a test run here to see if we get anything here. Got a pretty low FPS. That's fine, I guess. It's gonna tank really, really bad whenever we get over to that place there. So let's say we stop here. Now, for what I remember, it took a while for this to like do the things, like to get the instrumentation up or get all the nodes visible and stuff. But what's happening here? Now to trace application or in the process. You can save it to disk. You can do this. Okay. Keep all traces on Anchor beneficial to compare. Yeah. You can also share the trace. Okay. Trace files come to you can open a preview. Okay. Global Tracy has a variety of settings can be adjusted to your needs. The thing icon on the welcome screen. Where you can expand the global settings. Cool. Okay. Instrumentation is powerful feature. Yeah. Open a source file, include a Tracy header. This will give you access to a variety of macros. Now, when you profile your application, you see a new zone appear. Yep. Tracy can handle a lot of data. How about 100 million zones in a single trace? Wow. Add a lot of zones to your program, see how it handles it. Capture a long-running profile trace is easy. Need to capture an hour of program, you can do it. Note that it doesn't take much. Make more sense to instrument every little function you might have. The cost of instrumentation itself will be higher than the cost of the function in such a case. Right. Once you have instrumented in the application, you can view the statistics for each zone in the timeline. This allows you to see how much time spent in each zone, how many times it's called. To view statistics. Okay, but why am I not seeing the traces here, though, or the zones? You can search for zones. You can open statistics window, click an entry there. This open find zone. Okay. The histogram. Note that you can draw a range on a histogram to limit the number of entries shown. In addition to instrumenting functions, you can also instrument frames. This allows you to see how much time is spent in each frame of your application. Oh. To instrument frames. Okay, I don't think I've done this. You need to add a frame mark macro at the beginning of each frame. Okay. Well, this is, I can do this. When you profile your application, you will see a new frame appear for each time. Okay. Maybe that's why we don't see it. Maybe they changed how this works. I don't know. This used to show like all the nodes and all stuff. But if we open this, we can see a bunch of stuff in here. So here you can see where most of the time is spent. And it's in the AABB intersection part. Interesting. Yeah, I've already tried to do a whole bunch of upgrades to our quad tree implementation and all that. But let's see here. So let's actually do a frame. I'm gonna discard this. Yeah, and I'll do a frame thing. Oh yeah, we got leaks. I need to fix that because it's gonna it takes a while to like close the program. But yeah, cool, we got it working. So let's see. What do we do now? Yeah, the frame. Yeah. So I think it's like game update. This is basically the frame function. If we see where this is used, it's used. Okay, this is basically the frame here. So this is the loop. Well, actually, this is the frame. Sort of, I guess. So Z-tracing. Let's get our Z-tracing here. Or maybe not. Oh, we don't have Z-tracing in the game. I wonder if we could just expose it through the game engine. So if we just say public, and then this would be ZGE C tracing. Wait. Where did I put it? Oh, I see. I think I did it here. Yeah, that was stupid. Should be in here. There we go. Yeah, okay. Now we go back here and we should have an error here. Okay, cool. Now we can do frame mark, I guess. It's a function. Okay. I mean, I guess we could use maybe framework, or we could use framework start, and then in the end we would use framework end. I don't know. Maybe framework also works. I have no idea. Or maybe you need to do all of them. I don't know. Also, what is this? Do you need to have a name? Like, when would you use this then? This also needs a name. Okay, yeah, you didn't see that, but okay. I want to get back to the information there. Okay, let me Google on this. So Tracy frame mark. Where the hell is this? I went into the wrong thing. No, Tracy frame mark. Wait, it's a download. Okay, to mark frames, we use the following calls. Name can be omitted as an optional argument. It must be null term in the constant string to collect the frame images. Use it. Oh. Do you mean you can take screenshots or what? That's cool. Trace image can also collect matrix after proper encoding. Is it okay? Wait, there's no more explanation. Like, what does this do? Do you have to call this first? I don't understand. Fortran. Okay, zone markup. Zone begin call mark the beginning of a zone, but that's the zones, so that's not the frame. Fortran API. Awesome. Man, I need to try Fortran sometime. It would be cool to try like a bunch of these older programming languages to see if they have like features that have like been forgotten today. That was like, oh man, that was a nice feature which doesn't exist anymore or something like that. Okay, here we go. Scoped zone. So this is the actual, right? This is a Python. Okay, this is the actual loop here. So we've got the frame mark. Okay, so they only use like frameworks. So that was kind of what I was thinking. Like, it's sort of, I guess, it's like. So, I don't know. Can you decide if you want to use mark or mark start or frame start, frame end? Then, and this is the only. Is that the only place where this is referenced? There's no example to frame start. Okay. I'm gonna assume that you can either choose to use this or this and this. I'm gonna use start and end just because we're in Zig and I'm not sure if this works fully. So I'm just gonna use start and end, and this is a frame. Did you also need? Yeah. Okay. There we go. What's up with the LSP, man? Okay, I have no idea what's going on with it. I think this is only LSP things going on here. I'm pretty sure. So I'm just gonna ignore that. All right. Cool. It compiled. So let's run. Okay, will we actually get the frames now? Oh, here we go. We got a bunch of stuff here. Let's stop and see what's going on here. Frame set, frame. I mean, yeah, it looks like they are there. You know what? Let's do like in their example as well that they had as well. Let's see. Yeah. They had a scoped zone. I guess S for scoped with a name. Source location, name. Wait, what's the I32? Oh, that's the color, I think. So you need that. You need a frame name, and then we also want a color. I forget what the format was now, so we'll go here, we go to main. You can also do, okay, let's do without. Okay, I guess this would be the same thing. And they return what? Zone context. And then you do that. Let's see if that changes anything. Wait, what the hell is this? Now things show up. Okay, maybe it just takes a little while for it to show up. Let's discard that. Connect again. I just want to see how this looks. Alright, should be enough. I wish it would show like if it's currently crunching something here. What's going on here? Okay, here we go. This is also kind of weird. It's only showing like over here. But we do get a bunch of So here's how it looks. We can see one frame here. This specific frame took 10 milliseconds, which is, it's better than 60 FPS, so that's fine. But we are profiling, so it takes longer as well. And most of this is the physics update, and you can see how the physics system works here is we've got like, I think it's like 8 subdivisions of time for the physics update, and that is to increase the precision of the physics simulation, as I've read. Now we can see also that, let's see, we've got some tiny things over here. So this is update position. This function is basically going through all bodies in the scene and updates the position based on velocity, gravity, and all that. So that is actually quite fast because that is fully vectorized. And there's not much going on in this scene anyway, so it takes like 20 microseconds. That's pretty good. Okay. Then we've got this, which is the collision part. So this checks all collisions. It basically gathers information about all collisions that are currently taking place that we should worry about for the physics simulation. And then in the end, we also have this resolve collisions, which goes through all the collisions and resolves them, which means that it changes like velocity and position of things to make sure things don't go through each other and stuff. It's just for the physics simulation. So if two things approach, they collide, it's up to the resolve collisions to make sure that they collide in the correct spot, and their velocity is changed and all that. And then we go again. So update positions, update collisions, resolve collisions, and we do that 8 times throughout the whole frame. And that's basically it. And then the rest here is some game logic, I think. Yeah. Here you can also see, like, we call this intersecting function. This function is called from, I think, the player, like some different perspectives. The player is checked against basically everything else to see, are we colliding? Do we need to pick up any items? Do we need to, are we standing near any NPCs to talk with them? Something like that. So it's called a bunch of times, but each time it's called, it's basically nothing. It's like 10 microseconds, not even that. So so when we actually have the quad tree and everything is like, when we actually want to check for collisions against these specific things, it doesn't take up that much time. But the physics update itself, like this, gathering all the information about all the collisions, that is what is taking most of the time. And I would assume that that is also the case when we actually get to the gems later. This is gonna crash the whole thing, I think. But yeah, I don't see any issues here. It's taking longer because of the profiling. So I don't think there's any issues with this right now. But what we're gonna do is I'm gonna minimize this and then walk over to the place where we get the lag. I would also be interested in checking what the lag is between going from this section over to the next. I do want to see why is this lagging so much. Also, probably over here we already see a whole bunch of lag, and it probably is to do with just because we're in a larger map right now, and there's way more things to check here. So that could also be the case. Sorry about this lag here, but actually this could be a good place maybe to check. I'm gonna let's save this as like, I don't know, kottefolket village. Yep. And then we'll connect again. So we'll wait, did I stop it? I think I did. And then reconnect. Wait, I'm no longer able to send. What? Okay, let's retry this here. I'm just gonna go over here. Go in a bit so it might have settled. Okay, now we connect. Okay, there we go. I'm gonna walk around a little bit. Okay, stop. It's gonna gather some thoughts here, I guess. Yeah, I don't know why it stops like over here. Like, why does it stop here? Maybe it just gives up or something. I don't know. But we have some. Let's go over here somewhere, and we can see the frame now takes like. Well, it actually just takes 10 milliseconds. Maybe it just lags. Maybe it's trying to show the actual what it would have taken if we didn't do the profiling or something like that. I don't know. No, here's 23. That's more like it. Okay, so it's not that much of a difference, and we can still see that it's the update collisions that takes the longest time. And we can see, you can also see here, there's how it's built up as well. So basically, we do 8 update collisions. However, we are also reusing the code tree. So this is the part where we're using the code tree. The first pass here, we're creating an entirely new code tree from scratch, which doesn't really take that much longer than the other. So it's pretty quick. So we could do that every time. However, my idea was that since the quad tree, it builds up everything, every entity and stuff in it, and then the subsequent checks here is basically to increase the precision of the physics step. However, since we're subdividing one frame into 8 like sub frames, the difference in positioning of these entities are not gonna be that much. So there's like very little chance that one entity would cross over to another quadrant, let's say. So what we're doing here is that we're trying to utilize that fact. So the first thing here, the first subframe, we're actually building the quad tree. Then we're keeping the quad tree, and we have a dynamic quad tree version now, which basically it does a very fast check to see if the entities are still like in the same quadrant, I believe. And if they are, then we can do a quick check there, I think. Something like that. That's the idea anyway. So then we don't need to rebuild the whole tree. We just need to update those entities that are now like should be in a different quadrant, or they are like should be in multiple quadrants depending on if they cross the boundary and stuff like that. So that's the idea with that. Back to 2D, yes, Blue. So yeah. But as you can see, there's not much difference between this and this. I wish I could maybe look into this a little bit more to maybe see that we could utilize this fact even more. I don't actually remember now exactly how we optimize this, but we could look at that. And then you can see that this takes quite a while, and it's because there's a lot of things happening in here. There's a lot of these intersection checks going on, and unfortunately also probably a lot of them are also like not that close in memory as well, unfortunately. So that will be a lot of lookups that are like farther apart in memory. But maybe we can actually solve that. Maybe if we put, I'm not sure if we do this, but maybe if we just put all the when we populate the quad tree, we should also like if we I don't remember if we actually copy the rectangles. We could look at that, because each one here takes like, well, it doesn't take that long. Like, look at this. The actual comparison here takes like nanoseconds. This is like A, B, B intersection. It's like you're checking one rectangle against another rectangle. Orphaned means we're basically brute forcing all these. Orphaned means they are not part of any quadrant. But let's see. Pre-copy ABBs. So maybe we do that. This takes like 38 microseconds. I mean, it's not bad if it only has to be happen one time. So maybe we already do that. Yeah, this is populating. Also, we're checking intersection as we're populating a tree as well. So then there's less to check against for the first entities. Later entities will have more to check against. Then this part is only checking for intersections, except we're also updating a little bit. We're updating positions at the start. That doesn't take that long. Well, 32 microseconds. And then we're doing just a intersect check. But we can basically see that the populating part of the quad tree basically doesn't take any time almost. It's the checks that takes time. Here, for example, this takes, like, all of a sudden you get this here. I would believe this is a cache miss. Because it's the same function here, all of a sudden it takes way longer. And then we also have the intersection handler in between. The intersection handler is gathering information about what has collided. So, what it does, yeah. Like you can see, there's not much cache misses, I don't think, here. It's just that we have to do this a whole bunch of times. Okay, you know what? I'm gonna try something here, maybe. We'll look at a test. So I'm going to... one second here. I'm gonna open up this, and we'll go to, here's the quad tree, and here are some constants here. So pages, a little bit of definitions here. So pages are the kind of layers, or each page has the 4 quadrants, you could say, in it. Or no, sorry. Let's see if I can remember this correctly. No, I think that's correct. Yeah, each page has 4 quadrants, I believe. Yeah. And so the initial page has the 4 quadrants that divides the whole thing, and then each subsequent page would be smaller. And here's like max entries in page is 30, which means that if it exceeds 30, I don't remember if it like creates more subdivisions or if it needs to put the entry like in a parent page instead. I don't remember. But these are for the whole page, I think. Like a page can have the entries. An entry is basically, you know, an entity, like a rectangle that is connected to like a something, like a player or a monster or something like that. And then we have min entries for subdivision, which means there can be up to 10 inclusive, I think, entries in a quadrant before it further subdivides. So if it's like 5 in a quadrant, it doesn't subdivide. If it's 20, it will start to subdivide into smaller quadrants. Okay. I'm not sure what this means. Page levels padding. How many levels to make space for after the pages needed calculation depending on the number of entries. How many levels to make space for? Oh, I see. So I think it's like the pre-allocating. It's for pre-allocating, I think. Yeah, okay. So let's see. What was I thinking about that we could maybe solve this issue? So basically how it works is the game has also like collision groups. That is usually a concept you would see where you would enable collisions for certain groups against other groups. For example, the player has collision enabled for ground, for example. And ground, all the ground are static, so they are basically, Yeah, the thing is the ground is static, so we don't really need to check collisions for ground against ground. That was what I was thinking, because there's so many ground objects in that area because of the larger map, that I think that is what is making things go slower, because there's so many ground entities. But really they are all static, so there should be some kind of optimization maybe we could do with that. That was what I was thinking. There's already, like, we don't really, if something is static, we don't actually check collisions for that. So that is already a thing. However, for the player, we need to still check against the ground, but we're doing it through the quad tree. So, but we still need to populate the quad tree with all these ground entities and stuff. But I was thinking maybe if, so because the ground entities, they are part of the ground collision group, and since they are not colliding with other ground entities, maybe we can do something for checking intersections of the ground entities against other things. Maybe even like have a special case, like in the quad tree, when we check for intersections, if something is static, we just skip that one and let others collide with it instead. The problem with that is there is like an order-based collision detection going on as well. I just need to think about if that's going to be an issue, because the tree is kind of built up as it's also checking for intersections. So either you have an entity spawn first, checks against nothing, and then you have a if a monster, let's say, or item or whatever, is put into the tree first, there's nothing else in the tree, so it would check and nothing would collide. And then the ground is going into the tree. If it's static, we skip the check, so it won't actually check against the first entity now. So that doesn't work, because then we could miss collisions that it should have been colliding with the thing. I mean, maybe we could introduce other checks. Like, let's say we had a kind of bit mask that determined which groups you collide with, and if that rectangle has any things in there that you might collide with. So you have so basically we create this bit representation. So let's say, we have like a quadrant groups. That is which groups are contained in this quadrant. And then this would be like, how do you do, like 0b? Yeah. So let's say, you have a bunch of groups here. Okay, depending on how many groups you have, you can make this however long you want. Hey, Mutasimos, what's up? I'm doing great. How about you? We're back to some 2D side-scrolling metroidvania development. Currently trying to figure out how to optimize my collision detection here. Okay, so this is the idea. So let's say the first one here, this could stand for the player group. The second could stand for enemies, boss, whatever. Whatever groups we decide to have are gonna be stored in here. And then, so let's say we have like, this is the quadrant where we have a player, for example. Maybe over here is ground, something like this. And then if you, let's say we have a thing where it's like entity group, like groups. These are the groups that the entity will collide with. So let's say we have, let's say the player is colliding with, you know, let's say this is enemies, items, something like that. Actually, we don't collide with those, to be honest. We only collide with the ground, actually. So let's say we only collide with the ground. Now we can do a simple bit mask here. We can do like an AND. So we'll do like result. So has collidable entities is gonna be just, you know, entity groups and quadrant groups. And if this is more than 0, then we know that we potentially have a collision in here. But if it's 0, if there's no ground entities in here, we don't need to check this one. Maybe this will be good, I don't know. Because it does cost, like this operation doesn't cost much, but I think the branching the branching will maybe cost a little bit, maybe, I don't know. Also, I'm testing on my machine as well, so you know the benchmarks here is very limited what I'm doing with this, but yeah, maybe we can improve it a little bit. But this will kind of solve the issue, I think, for also the gems in the same place. Like if you have a lot of gems in the same place, they don't collide with each other. Maybe that will solve it for that. Although there should be a ground in the same quadrant, so that's not the case though. Yeah, I don't know. But it would skip maybe a bunch of quadrants. Another idea is to have maybe multiple quad trees for each group or something like that. So then you only check against the quad trees that actually have the entities you need to check against. Oh, you added particles to your game. Nice. How was it? Was it difficult? And also the Rust reviewer finally responded to the 3 weeks now doing the request. Nice. Maybe they're like bogged down with work or something. I'm just gonna refill my coffee. I'll be right back. Sort of difficult. Got it working first try. Wow, awesome. Like, how do you even do that? I've never looked into like particle systems. Did you create like a separate physics or what kind of like you have your own physics engine, right? I was gonna say, if you have your own physics engine, you have your, maybe you have like a separate physics simulation just for the particles. Maybe, I don't know. Let's see. Like, I don't know how much we'll win with this one though. This feels very specialized. Yes, the particles have their own separate physics, yeah. This is the thing. I think I wanted to do a little bit of research on groups, like how others implement that kind of thing. And maybe we'll also look at maybe a little bit more on what is actually taking time. It's just that we have all these intersection checks. Let's see. Like in the end here, particle system struct contains all particles and also helps draw particles open GLN instancing. Instancing is fast. Okay, I don't actually know what that is. Is that taking help from the GPU somehow? I guess, I mean, I didn't actually think about that. I mean, I'm not actually taking any help from the GPU with this system here. Except for like the rendering part with Raylib, but not for the physics part. So maybe there's a skill issue there. I don't know. Because this part, well, the whole physics update cannot be parallelized, but each individual sub step here can be parallelized. So all of these checks could, but no, actually no, not this first one. Actually, that is order dependent. Maybe that's bad then. Maybe we should just build a tree first. And then do a parallelized intersection check instead. The physics is not being done on GPU because the GPU is so scary. I wonder when we'll get Python on GPU. Yeah. Instancing is like drawing many similar things at once, so less draw costs. Oh, I see. Maybe I'll try to, now that we have I/O in Zig, maybe it's easier to do this now. I don't know. We could try to multi-thread this. I just feel like it's cheating. Okay, BRB, 1 second. I can think about this a little bit. All right. Multi-threading does feel like cheating. CPUs, you can make it faster, make more of them. Yeah, exactly. It's cheating. But I mean, if you look at all of this crap happening here, and you go down into like the individual ports, it takes like nanoseconds. It's just that we're doing like a lot of these. Even if we could make this also just take like nanoseconds, it probably won't save that much. I mean, okay, this is 2 microseconds. I wish you could see like how much. Why does this take so long? Intersection handler. So yeah, we get a bunch of intersections, we loop through them. Here we're doing checks, if it's static, solid. I mean, to be honest, if something is not solid, I think it shouldn't even be in the tree to start with. Okay, but that's not here or nor there. Are you doing caches? What kind of caches do you mean? So there is a step. Let's see. Populate intersect page by page. Oh yeah, this is the old version. Here's the new version, right? I forget what the difference was now. But yeah, there is a step where we copy a bunch of stuff. Here, pre-copy ABBs. Because the ABBs are... I mean... The thing is, like, if they were like so far away from each other, we wouldn't get these. I don't think we would get these nanosecond checks, intersection checks. You can clearly see when there's like cache misses happening. I think here, yeah, here's one for example. This takes almost 4 microseconds, while the other ones take like 100 nanoseconds. So they should be pretty. There should be like minimal cache misses in here. I think that's just my presumption. I mean, look at this. This takes like a lot longer here. I don't think that is a huge issue. The cache misses. I wish we could see like how many calls in total. I think we do have that. Let's look at statistics. Like this one, count 16 million. Can we check just one frame or one subframe maybe even? Is that possible? This frame? Okay. Can we limit? Wait, why is there 2 physics updates in one frame? Wait. That's not correct. What the hell? Hang on. Fixed update. Oh, is it? I think it's. Is that correct though? Can we do that? And then we draw after. So if if this takes, this seems weird because wait. I mean, I might be doing I might be doing this super weirdly. I don't know. I'm just like, either you do a physics update. It takes like, well, actually, the physics update is just supposed to take the time it takes. Like, it's supposed to be a fixed update. So you're basically telling it, hey, you should update one frame, and one frame with 60 FPS is like 16, 17 milliseconds. So that's not the time it should, that the update itself should take. That's the time we need to simulate. So it doesn't make sense to make multiple physics updates in one frame unless we want to play catch up, maybe. Okay, yeah, because look at this. This frame took like 100. Like the first frames where things are apparently taking longer for some reason. This frame took 120, so we got a whole bunch of physics update here to catch up with. And then we got less and less physics update. And then like over here, now we only have one. Okay. I was like, wait, are we calling it twice? And that might be an issue, but yeah, no, that was not the case. Okay. So this is fine. Like, it just takes 11 milliseconds. But I mean, yeah, it's a lot because there's not much real estate left now for other things. So physics in my game is very broken. Oh really? In what way? Okay, I wanna check. Like, okay, that's the poplet. Then what we do is we do just a check, update positions and intersect. Right. So this one, first we update positions. That takes not much time. And then we do search and report intersections. It's like, do we really want to call intersection handler every time, or do we just want to give a finalized result? I don't know, maybe it doesn't really matter that much. Well, maybe it does matter because of caching. Caching. Because this thing, do you actually do any checks here? I don't think so. You just create collision events. Oh, you do actually do checks. There's a subtle bounce when you land on the ground. You can slide very weirdly with blocks sometimes. Is it a bug or a feature? I was recompiling Rust itself and it kicked me out of the stream. It doesn't want you to look at other compilers. I mean, we could just try to do, we could. I was like, can we be very clever here? But we could just multi-thread it and see if that actually does anything. It's just that we have to change a couple of things for that. Like when we do whatever it is, the this one, populate intersect. We actually have to populate first and then do the multi-threaded check. The population itself, I don't think can be multi-threaded. Unless you're threading, well, the population itself doesn't take that much time anyway, so it doesn't make sense to do that. Actually, I want to just try and make just a pop. I don't even think I have a populate function, so let's just make populate. I'll just copy this part, or maybe even this one. And now we don't need the intersection handler, and we don't need the context. All right, so this is the P zone. Welcome to the P zone. And then this will be just populate. And we'll see if the page by page thing is like necessary, but reset, yeah, I guess we'll have that as well. So context, sure. Here we have prepare, calculate pages needed, prepare to add pages. Sure, I think that should be fine. Add pages, pre-copy zone. So what does this actually do? We're going through all the entries. Right, so we're copying all the rectangles. That's fine. And then we allocate what? Yeah, we allocate some stuff. And populate page, search and report intersections. Wait a minute. So is this just populating everything first? Populate page. Yeah, I think this populates everything. And then it does. So we already kind of do that. The population itself, yeah, it doesn't take long. Like this is the startup here. The startup takes, you know, all of these over here. So it's like 2 microseconds, 30, 40. So let's say 50 microseconds to populate the whole quad tree. Right, and then we're doing the intersection part. So ignore the whole thing I talked about earlier where it's like order based, because it's not, apparently. So the only difference is we don't call this. Okay. And then we should be able to just call this from page by page here. And we should just be able to delete all this basically and just say, well, I do want to keep the zone here, but just populate. Okay. Oops. So now we have like, this is actually just populate first and then search and report. Okay. So populate does everything that we did before, but now we have them separated. Okay, what was the idea? I forgot. So we populate, right, so if we want to do multi-threading, well, we already have the populate function, so that's good. Let's, do we have session here now? Let's just add this. Oops. Zig build. Actually, this could be like overseer. Zig build run. And let's also enable Z tracing. There we go, although you don't see the thing, so let's do that. There we go, so there is our little thing. I just want to make sure that it kind of still works. Okay, it seems to still work. Cool. Now, oh yeah, so Mutsimus, your collision, what was that called again, your collision system? Or the algorithm? Was it sparse? Octa? No. I don't remember. Sparse something, right? Which I could call this quad tree sparse, I guess, as well. It's just to describe how it's populated, I guess. AABB intersection. But I was thinking of the whole like world, like with the voxels and everything. Oh, you're not using sparse voxel tree because it's difficult. Oh, okay, okay. So, okay, but how do you how do you optimize? How do you call the collisions? Because I'm gonna guess you're not brute forcing it in a voxel engine. Like that would be a lot of things being checked, right? Can you do like a, you could probably use like a sweep in 3D. Like you could do like almost, maybe you could do like multiple sweeps or something. I don't know. Selecting the block the player's close to and checks inside there. Ah. But how do you select the block that you're close to? Convert the player position to the block position. And check with that. Are you saying you have all the, are you saying you have the blocks in a 3D kind of array with a flag if it's there or not? Or what, how do you actually like, what's your method for doing that? I mean, I guess it's kind of easier if all the blocks are like aligned. They are sort of in this what's it called? A grid. Man, what's the math term? that I forget. A lattice. You should try using BSP. Just kidding. I have a hash map of chunks, and the chunks contain 16 cube blocks. Right. Okay, so you're saying that you have a... So the world is it's in two levels. You have the chunks, which are 16 by 16 by 16. And then further down you have the blocks. And then you're converting the player to a chunk coordinate, maybe. So first, okay, and then you're checking against the blocks. Or maybe even just the neighboring blocks. I guess it's way easier when you have like when you it's like that, maybe. I don't know. Instead of having like arbitrary bodies everywhere. Yeah. I mean, really, since my system is... Actually, that's actually a great idea, because my system, the tiles are not even supposed to be these advanced collision boxes. So, I mean, I could just try to use a tile-based optimization algorithm instead of adding the ground to the quad tree. That would probably solve this whole issue, although it wouldn't solve the gems brute forcing 30 entities in the same space, because that would be like 30 brute forcing other 30. It will be like 30 times is it 29? Yeah, 870 checks. I mean, it's not that big of a deal, really. 870 checks is I don't know. We'll see what takes time over there. Okay, enough of this. Let's I'm gonna try and see if I can multi-thread this, but I'm just not sure how. Like, do I need to prime some threads? I know that creating new threads takes time, so we probably don't want to spin up new threads every frame, right? We probably want to have some threads ready to go. Wait, this is not container. Okay, so like, I'm pretty sure this the concern should be in here, so I guess I'll add IO here. Okay, I will say something here. This thing, the order arguments has been something I heard that people complain about with allocators. I can understand that, because I also got used to allocator always being the first. If you have a function that takes an allocator, it's always, in the case of the standard library, and all my functions that I've done up until now, it's always the first argument. However, with the update to 0.16, where we now have I/O, they've actually changed that. So now it seems like allocator is the last argument sometimes. I haven't checked like all functions, but yeah, the order has changed, and I don't know why it's changed. It feels weird, but I/O is now like first, and then allocator is like the last argument. I mean, I know it's like nitpicking, but it's just why was it done in that specific way? it's just something that it's a little bit annoying when you got used to, like, I mean, yeah, sure, we can get used to the new way of doing things, but it just makes sense to, why wouldn't allocator be like part, like you would understand, like allocator is like one thing that is almost like universal, like, and it would always be like at the first spot. But then I/O came along, and now I/O has kind of the same status as the allocator. It's something that you need sometimes. It has like the side effects that you can't get otherwise. So these two are like twins in that sense. So why is it like, why wouldn't they be together? It's such a weird complaint, but it's like, I can understand like why they now that I/O is part of this, that allocator might not be the first. Maybe I/O is the first and then allocator is like, but please, it's nice if it has like a specific order, because if we have this pattern, it can be used everywhere, so that you don't have to think about, okay, which parameters should be the allocator, which should be the I/O. It's already like built into this pattern, so that you can always just follow the pattern. But now it feels like there is no pattern almost, or maybe, you know, I haven't looked at all the functions, but it seems like I/O is first and then allocator is like the last. At least that's what I've seen sometimes. So I mean, that's just weird. Like, why not put them like first, both first, in a specific order? Why put allocator last? Okay, anyway, end of that rant. I don't know. Because I don't know. There's something going inside me that goes against having allocator last. That just feels super weird, but okay. It's just something that you have the kind of main dependencies first, sort of, and then the kind of arguments after. I don't know. Anyway, now it's end of that thing. Okay, so let's add this I/O here. All right, and let's see. I want to check this sometime. Like, is there a consistent way of doing this? Because I do want to follow it. It's just that I just want to know what it is now. Then instead, so that when we change these things, we can change it to the correct pattern. Anyway, I wish it didn't matter. I wish I didn't have to think about it, but yeah, it's just something that you got used to. Anyway, now we have the I/O. The I/O can do a whole bunch of things. So, for example, I think here, can you do like a cancel? Maybe not on the whole thing. There's no D in it on the thing. It's like if you have like things going on here and you deinitialize the thing, you probably want to like cancel whatever's going on like in your threads. So that is something that you could do. I don't know, what is recancel? Asserts that error cancel was returned from a previous cancellation point. Okay, no. Okay, but anyway, I think that we probably want to have like a couple of threads that we can access from in here. Maybe? I don't really know actually. Threads. Threaded. No, that's... I mean, maybe... Maybe there's like handles that you get or something. I don't know. I don't know. It's only gonna be happening in check collisions here, so it's like you can call async. This will spawn something somewhere, somehow. I'm not sure if this always spawns a new thread. I mean, I guess it would have to if it's gonna be async. Probably. Like, I'm not sure how this threaded thing works. That's the thing. Maybe we'll have to read up on it a little bit. I'll just go to the documentation actually real quick and see if, like, the release notes, because there was a section about the I/O interface. We did read this last time, but I'm just going to check it based on threads with this implementation. I just want to know, how does it spawn new threads? How do we use it? How can we have more control and so on? With this implementation, I operations are straightforward. For example, file system operations directly call, read, write, open, close, etc. When updating code from Zig 0.15 using this implementation provides the equivalent behavior. This implementation is feature complete and well tested, including cancellation. This is the implementation currently chosen by JuicyMe. Okay, so but what if you call async? What happens then? Future task level abstraction based on functions allows introducing operational independence among any set of function calls. Yeah, see, so here we don't really use like async. I think we just pass IO in here somewhere. Where is that? Request. No, yeah, the client takes IO and then we call request. So it's all handled in the client. So we don't actually call like async in here. The code also works when compiled with single thread, even though the operations happen sequentially. When upgrading code, if you find yourself with access to an IO interface, you can, without access to an IO, you can get one like this. What? Oh, so this creates a new one, or wait, this works as long as you don't need task level concurrency. However, it is non-ideal workaround, like reaching for a page allocator when you need an allocator and don't have one. Right, I see. As long as this works as long as you don't need task level concurrency. Okay, yeah, but it can be used for other things like random and stuff like that, right? Okay. Is there better accept an IO parameter if you need one? Right. Yeah. But we are doing that, so that's not an issue. Futures or task level abstraction based on functions. So essentially, if you do this, you can't call async then, or is that how I'm supposed to interpret this? Async expresses asynchrony, that a function call is independent from other logic. Creating such a task is therefore infallible and portable across limited IO implementations, including those which lack a concursive mechanism. So it's like if you don't have it, will it just run it synchronously then, or it is legal for IO implementation, or does it run the function when you call wait or something like that? I don't know. It is legal for IO implementations to implement async calls simply by calling the function before returning. Right. Yeah, so I understand that. I guess you have to go into the threaded implementation to see how it's used there. I mean, we can do that. We can just go there and look. So we could just go to, standard IO threaded async. Where's the V table at? So here's the async function. And there is our context. If we are single-threaded, we call start, which is the function. So we just call the function. Okay. And then return the thing. Right. Otherwise, we're creating a future. Okay. This doesn't take IO or anything. No. We create a future. Okay. So this, I'm gonna guess this just creates. No, it does a lot of things actually. Forward. It does a bunch of calculations, I guess. Yeah. And stores this over here. Okay, and then we copy some stuff and then we return it. So it doesn't do much of anything. It just creates a struct there basically. And then we lock that thing, and then we have a busy count. Okay. Had to go eat lunch. I'm back now. Right. Was it a big lunch? I'm gonna have to do that as well here in a minute. Busy count. Async limit. T is our context, right? I see. Right, so it's like how many threads are currently going or something like that, I don't know. Or how many tasks, I guess, futures. Maybe other things as well. So if we're exceeding our async limit, we unlock the thing. Okay, then we just run it. Okay, I see. Why wouldn't we check this before we created the whole thing? Because we're like locking and then unlocking, destroying the future. Like we don't need to do these things if we do this up here, right? Or am I missing something? Okay, anyway. So if the busy count, if we can't spawn any more async tasks, we're basically just running it directly and then we're done. Cool. Here we have like pool size, wait group value. So it's, I mean, yeah, it seems like they are actually spawning these threads. But the thing is, how much time does this take? Like spawning a thread seems, at least from my experiments at some point, it took like a pretty long time to actually spawn a thread. Like from with the operating system. Maybe it's different also like Windows and Linux, I don't know. But I mean, obviously there's probably some kind of difference. I know the Windows have something also called fibers, which I have not really looked into. But this is, you know, agnostic to the operating system, so. Okay, so spawn. Spawns a new thread, which executes function and returns. So it's, I mean, essentially just spawns the thread, but can't we have like a thread that's always running that would tell like, hey, could you, we've copied over some data, could you process this, right? I don't know. If pool size negative busy count is 0, maybe this is what the thing is, like if, so pool size minus busy count. So let's say pool size is 2, busy count is 1. That means we don't go in here because we have something in the pool. But where does it start that then? Release the obligation of the caller to call join and... Oh, I see. So what happens if this is false? It just goes here. Are you compiling Rust again? Okay, yeah. Sorry, Rust. I will try Rust at some point in the future, maybe. Run queue prepend. Future runnable node. So it does this even though we've done this. I don't really understand this part. Is it so that we know we can check a wait group? All threads are spawned. Wait, okay, I see what's going on. So basically we can't exceed the pool size. If we don't have anything less left to spawn with. No, because we're spawning in here. But when do we spawn later then? Do we just don't spawn it? No, because we have the... We do this anyway. I don't understand this part, but maybe I'm just... I don't really understand. Okay, whatever. But basically we spawned a thread. I just wanted to know if there was a reused threads or something we could use later. I don't know. Let's just try this, I guess. I guess we'll just trust that this works. and do this here. He confirmed it, yeah. Or did I? I confirmed that I will maybe try it. In the future. Sometime. Okay. I have tried it. I have tried it not on stream, but some time ago when I was curious. Actually, like I remember the first time I heard about Rust, I never really looked into it, but for some reason I got the idea in my head that it was just like a modern C++, basically. And so I never really looked into it. I never got into it until I think I saw someone use it, and then I was like, wait, this is really different. And then I got a little bit interested, but then I just tried it, and that interest went away. All right. Okay. How do we do this? I think we'll divide the checks into some number of threads. So I guess we'll just have like number of threads. I don't know, 10 threads. Wait. Where's the thing? Check collisions. Here we go. So, how do we do this here then? I think what we'll do, the first thing we'll do is not worry about this. I will only do this. But the trouble is now, I think we probably need to forward threading into here, because I don't see a good way of, like, how could we from outside divide it up, basically. Actually, how do we divide it up in the first place? I mean, I guess we could take the first 4 quadrants, divide that up in each thread. IO. Actually, let's just not worry about number of threads. Put this here. All right. Wait, here we're looping through each entry. Yeah, okay. That does make sense. I guess what we could do is we could, well, I guess we could divide let's move this over here, I guess. Number of threads. So what we'll do is we'll have the, so we have the index. And we'll try to, I guess we'll section it up, or The thing about this intersection handler as well, this should probably be like a mutex calling this, and then it's probably better to not call it until the end. So we'll gather up all the data first, and then we'll go through the data sequentially to call intersection handler. However, we're gonna have to mutex and it's something anyway, probably, or do we? Each thread could have its own result. Actually, yeah. That we just basically go through each result later to handle that. Yeah, because this intersection handler, it can't be called in one of the threads or multiple threads at the same time. It's not supposed to be that, to do that. So I think we'll just gather up all the intersections first with threads, and then like go through all the intersections. So we'll have like I guess all intersections. I don't know what to call this. Array list of these things, which is intersection K. Yeah, we get a bunch of these things. And actually we could init capacity and number of threads. So we'll have one for each thread. We don't even need an array list, to be honest, for this. We can just have an array. So this would be like number of threads, intersection equals 25. There we go. There we go. I also finished writing my compiler, but the code it emits is very unoptimized. Wait, which language was that? Okay. So we have all the intersections. Now I think I want to do something like this for each thing, and then later we'll go through all intersections, and we'll just call the thing there. Right? Oh, entry. Ooh. Wait. Oh yeah, this is per entry. That's right. Hang on, this is a little bit different. I mean, I guess this could be a... Actually... Okay, so we've got entries times number of threads equals this. No, entries times number of threads. The thing is, we don't know, it's not comp time known, so we actually have to either allocate this. Yeah, so we will have to, oops, we have to allocate and the thing we allocate is this. And we allocate number of threads times entry length. There we go. Actually, all right. So now we have all the intersections. Look at this. Can you do this in Rust? Oh man, time flies. All right, so this is the part we want to threadalize. So we'll go through all intersections. The question is though, now to get the entry, this is going to be entry values, which is going to be I mod entry values length, right? Because we have number of threads times the entry values. So if we mod by entry values, we should get this. We should get the correct. There. And so we'll loop through this. We have a type standard called results TE, where either OK or error, and T is the success in error type. Yeah, that's like the either type in Haskell, although it's more appropriately named. Although the Haskell type is more, I guess, it can be used for other things. It's like either you have the left, it's like left or right. Either you have the left type or the right type. I think left is used for, is that the correct type? And then the right is used for error type. Yeah, or other way around. I don't remember. But it's the same thing basically. So I am familiar with that structure. You can also add the suffix question to pass the error up to the caller. Yeah. All right. Right. So in Zig, the equivalent would be to say try. So instead of doing this, you would do try. However, then I need to change the type here to an error union type, and that will propagate up. So now I have to change a bunch of places. And since in this project, specific project, all errors that stem from allocation errors, which is just out of memory errors, I do catch unreachable, and that is only because. And so what this does is basically we just ignore the error in compile time. So it basically it's kind of like saying, hey, this error can't happen basically, but it can happen. So, and when it happens, it basically just crashes here. But it's an out of memory error, and I kind of got this pattern from the library, entity library, or the ECS library that I'm using, and I kind of stuck with it. So now it's everywhere. At some point I will change this to so that we have error unions instead, but yeah. Essentially, yeah. So it sounds like the question mark is exactly the same as the try keyword in Zig. Only if the function you're doing question mark in also returns the result with the same error type. Yeah, so that's the same. That's the same thing in Zig then. Result can do unwrap, which unwraps to give you OK. Yeah, okay. So this is kind of like unwrap then. This is like unwrap, because if it's an actual error, this will crash. If it's not an error, you unwrap it. And I believe Go also has this kind of thing where errors are values as well, but I don't recall exactly what the syntax is there. But yeah. Result can also do map, which maps values on the OK value. Okay. Yeah, that's kind of like that's kind of like the in Haskell, or you can also do map or f map or functors. There is not really an equivalent in Zig, although you can easily define that function. You know, error map. You can even have a generic if you have like the error type. You can probably have like E, and then you have well, actually, you don't even have to have the error map. You can take the value can be any type, and then you have the function, which is a pointer to a constant function. It takes x, which now we kind of try to. You can actually extract the type from this, from the value with. So basically, you take like type of value, and then you need a type info. You can make this into a function as well, so you don't need to put everything here. But since we know it's an error union, you can take error union, and then the payload. That is the type that we're interested in, and then the result type. That's the thing. The result type is unknown really here. So actually we can't really define a type for f as well. We actually need to say any type for that also, because we need to extract the result type as well. So but now you can do the same thing here. For the result type of this whole function, it's going to be like type info type of f function return type. So this is the kind of the resulting type if the error is a thing. But then you now we have to do like, wait, where's the error? How do you construct the error union? Because they made this. Well, actually, you can do this. You can do type info type of value, and then we assume that this is an error union. So we get the error union, and then the error set, and then we construct a new type with the error union operator here, and there we go. Now we have that, and then we return. Well. Now we have to check. So value can be an error. So what you can do is you can do if value, if it's okay, we get the okay value here, and then we can return. Let's do it like this. We can return f on okay. Otherwise, we get the error like this, and we return the error. So this would be the equivalent. So now you can use error map. Now mind you, this will probably not work that well with the LSP. It will work with the compiler, like it would be able to figure out which types are passed and on all that, but it wouldn't really work with the LSP probably. Like if you pass some type in here and you get the return type, the LSP wouldn't be able to figure out. Result can also do map, which okay, yeah, you said that, or that I read that. So you can actually define this function in Zig, but that's not the way they're doing it. I think that in order to figure that out, it's basically the same thing. You do if, you know, actually, yeah, if allocator allocate, you know, then we get the pointer to the thing. You have to do this else error. So this pointer is now the allocated pointer. And then this error is what happens with out of memory. So it's like you have to kind of deal with the error as well. I mean, it's kind of the same thing, except I mean, it would be convenient with the map function. It's just that usually you don't really, that it's not like it exists in standard library, but you can define a function like that. Map error maps on the error value. Unwrap or which returns the OK value or the value given to the unwrap, or else it's like if self is okay then return okay. Yeah, okay. So there's a whole bunch of convenience functions there. Maybe Zig will get those things because it has the. I mean, maybe there already is. I don't actually know. Is there like an error? No, there's no error like package or anything. But oh yeah. But it has the capacity to define those functions. It's just I don't know if that's the direction that we're gonna go or something like that. I don't know. Anyway, it's just that they don't exist in the standard library, but you can define those functions if you want. So I'm thinking here. So we're going through all the number of threads. What we want to do in here is we want to spawn a thread to run, you know, part of the intersection checks, and then store result in all intersections. And then in the end, we just go through all the intersections. We get the entry calculated from the thing, and we do that. Yeah, and you know, it might be that some of the sections are empty. That's fine, I guess. We'll see if this actually saves any time here. But I think that then we're gonna move this to a separate function. That will go through all the entries. I'm just thinking how to organize this here, because how to round up the results of the threads. Because essentially, I think this should return a bunch. I mean, this could actually return a bunch of these intersections. We don't need a handler. We don't need that. Search and report intersections. This would be like partial or something. And so this would be like all sections or entries. No. Well, whatever. Let's just keep going with this. We allocate a bunch of these. These are not number of threads now. These are only however many entries we have. And then we get those intersections here, and then we just populate this with the intersections. Or we can just... Oops. How do you go back? A 0, I think. like this. And then in the end we simply return this because it's allocated. Okay. Now this allocation could also take up time, so we could have this like result space could be, you know, primed up once and then returned. We could even like get a slice into, actually that's probably better. We get a slice into where we should store it. Yeah. So this would be section K. Yeah, this is much better. Here we go. And we don't need to do that. We don't need to return. We just set that there. So we just basically just get the slice that we need. We implement or we populate that, and then we're done. This would have all the things we need. We do this now. So, and then this would just go through each one, and that should be fine. Yeah. So, okay. So this will be like IO, async. Hang on. We also want to have a, I think we want to have a group or something. I might leave several times now because I'm testing Rust compiler against every compiler UI test. Oh, nice. All right, yeah, you do that. Let's see. I think, do we need to have like a group or something? I don't know. Do we need a batch? Do we want to have a group? Do we want to have a whatever it was called, something on S? What is an operation? Concurrent. What is the difference? Concurrent, async, calls functions with args such that the return value of the function is not guaranteed to be available until a wait is called, allowing the caller to progress while waiting for any IO operations. This is a stronger guarantee than async, placing restrictions on what kind of IO implementations are supported. Well, by calling async instead, one allows, for example, stackful single-threaded blocking IO. Okay, so does this mean that if you call this while having like single-threaded on, this will crash, or what's going on? Okay, so it calls concurrent. Yeah. Okay. It would be cool if they could say that instead, like if you have single thread on, this will crash, instead of this roundabout way of saying. But yeah, anyway. Hope I'm done with my pull request. Is that what you're testing now before you merge it? Are you responsible for clicking like the merge button, or is it someone else? And if you like, if you haven't run the tests and then all hell breaks loose on the other end, what happens then? I'm just gonna refill my coffee. Be right back. All right. Alright. I wonder what the reviewers would say looking at material commitments of personal project. Well, they wouldn't do that, right? The reviewer accepts and a bot named Boars will add it to the queue. When it reaches the front of the queue, Boars checks it on many targets and then finally merges into the nightmare. Okay. So you're not responsible at that point, right? I mean, I guess you're kind of responsible, but essentially, but you have also like had a reviewer. It's kind of like a shared responsibility. I guess the reviewer would take over responsibility, maybe. I don't know. I guess it also is in the documentation for contributing or something. Have you read that? Bless the tests. Is that an expression? Update expected standards. Yeah. All right. So let's see. How do you create a group? Maybe you don't with this. Maybe you just say like IO group. What was the other thing? Select. Executes task together, providing a mechanism to wait until one or more tasks is completed, similar to batch, but operates a high-level task. So what's the difference between this and group? The provided tagged union will be used as the return type of the wait function. When calling async or concurrent, this one specifies which union field the called function's result will. Wait, when calling async or concurrent, the one specifies which union field the called function's result will be placed into upon completion. So, if I'm interpreting this correctly, you have a tagged union. The result will be like a map between the tags and like a list of results. So let's say we have this. And we like await. Oh, you can select different tags to await. Huh. Okay. Well, anyway, cool. Let's do group init. Is this a function? No, is it a function? No, it's not a function. Man, I hate it when I do this because init is like, it's supposed to be a function, right? Why is it like sometimes it's a function, sometimes not? Sometimes they just empty. Are they moving from empty, like this pattern? It's like we're mixing and matching patterns. I don't like it. But okay. Whatever. Init. Okay. So at least we know that we should look for init or empty, I guess. I wish it was like a better pattern, but the tests have been blessed sounds funny to me. And that sounds weird. Blessing is literally what they call updating expected standard errors, which is funny to me. Yeah, why is it called blessing? That's weird. That's culty. Is it only in Rust? Okay, we got our little group. So the group can then do async. I see. Cool. So now we do group async. We pass IO. The function is search and partial. The arguments, is it a tuple then? I guess. Yeah, it's an args tuple. So this would be like self allocator, all intersections. Actually, you know what? This is wrong. It's not supposed to be all, and actually, we also get. So this is the output. Then we also have the entries. That's right. Which are what? You are a const k. All right. So we go through the entries. But that's the thing also, I is not necessarily then correct here. So actually we do need to, well, this should be correct, but this one is not. So let's have an offset. No, usize. And so this would be I, and let's do j's offset plus I. That would be J, this would be I. There we go. So we have allocator. Wait, do we even need allocator? Actually, we do need allocator here, I guess. Yeah. Okay. Wait, index? Index is wrong. Yeah, that's wrong as well. I think this should be J. There we go. Important. Okay, good. Then we have offset. So offset would be, I'm just gonna say offset entries and all intersections. This would be I guess it's just off. Is it offset? No, it's like offset times number of entries. Wait. What is offset actually? No, it's offset is like part of entries. So let's say entries are divided by the number of threads. Offset would be like offset times the number of threads should be equal to entries length. And then all intersections are divided up like this, like hang on, have I thinking about this the wrong way? So really, each entry is just what we don't need number of threads times. This seems weird. We only need this, I think. Yeah, we allocate the number of entries to get each one gets a list. Yeah. Yeah, the other way did not make any sense. I don't think. Yeah, now this makes sense. And then entries is simply going to be entry values offset, same thing. and then offset is going to be actually this is like offset up until entries per thread plus offset. Or actually, this will be like the end, where end is depends. If we're on the last thread, I think we'll just dump the rest on there. Or we do min length or offset plus entries per thread, where entries per thread is, let's see, it should be something like, well, it's gonna be like div something. I don't know if it's floor or whatever it's gonna be. So it's gonna be like length over number of threads. So let's say this is 100, this is 10, it's gonna be 10, right? 10 per thread. That's divided even. However, if it's like, if this is like 101, then we still get 10, I think. But in the last one then, no wait, it should be ceiling then. I think this is the floating operation. Wait, it's not. Oh, we need to convert it. Let's do floor. Offset entities per thread times t. So when we get to the number of thread, when we get to the end, we're at like, this should be 9. So we start at like 90 and then run up to, I guess, 99. Yeah. Well, what if there's one more? Oh, you have to fix it. Did you have to bless it? Wait, is the blessing part, is it automated? Sorry about all the questions, by the way. It's just interesting, the collaboration part there. Wait, how do we deal with the last? If there's, say, like there's 101, we divide by 10, this should be still 10. I guess we could do something here, like if entries per this feels so bad, but if this times number of thread is less than this, so if 10 times 10 is 100, and we have 101, we have like a couple of ones left, then we do another one which takes the rest. On offset should be like 100. Yeah, then we just do the same thing again. Maybe here we could do like +1. Instead, we do like +1. And we'll do a check. Like if offset is equal to end or something like that. Or if offset is equal to we break. And then this would be like +1. So don't think we need to do that. Because then, let's say we are at the +1. This would be like 100, let's say. This is 101, so offset is not larger or equal. So we go over here and offset plus that, so that would be 100 plus 10, so that's 110. This would be 101. So we would end would be 101. We would do the same thing over here. We would begin at the same thing, offset end. Offset would be 100, I think. Yeah, 100 to 101. So essentially be the 100th index. Same thing over here. And yeah, it would be the same thing, because this should have 101 entries, because we're having as many as that. So this should equal that basically in length. All right. And then once we have so those will go in there, populate whatever part of this. This is all like sectioned off, so no thread is gonna mess with the other one's intersection list. And they have their own entries. We have the offset, so we can calculate the actual index. Okay, and then in the end, we need to wait for the group. And this could be an error. Cancellation request propagate to all members of the group and will also cause error cancelled. Not thread safe. Well, this is in one thread though. It is safe to call this function concurrently with group async or group concurrent, provided the group does not complete until the call to async or concurrent returns. Okay, so let's just catch and reasonable here. I don't think we're gonna get a cancel for this. I mean, we're not canceling, so I'm not sure where that would come from. It's not automated. You have to run. Yeah, but okay, so you have to run, but the actual process of blessing is automated. You don't have to like manually edit the code or anything like that. Okay, 1 second, I'm getting a call here. All right. Sorry about that. Yeah, but okay, so Mute7, what I mean is like you don't have to like change any code or anything for like it runs bless if you just pass -- bless and it will automatically update everything, or how, what? Are there any automated like updates that are done after you created like the PR, and it like does it do any commits, like automated commits to the code? Because that could just, if that's, couldn't you just set up like an automated fixer upper thing there? Okay, so we wait. Blocks until all tasks of the group finish. Great. Okay, we don't actually need the entry. Okay. Interesting. I mean, yeah, okay. Did we... No, there's some issues here. Oh yeah, you need IO now as well. So let's actually add that. I mean, I guess registry do have IO, so I'm just gonna grab IO from the registry actually. Instead. And you also get registry actually, so there we go. And then we don't actually need to store IO here actually, to be honest. We can just get it from the registry. Right, so I think, yeah, so IO is get const, no, singletons get const IO. Wait, and we have registry here as well, so that we don't even need that there. Okay. No, because okay, we do need that because we don't know if it's what that is. Wait. Oh. Oh, shoot. Okay, well... I guess we could do this as a first pass, and then we can add it to the other thing, just to see if this actually does anything for that. So let's see. Wait. Whoops. No, you need to be var then. And you take IO. Oh. then we do need IO here. Okay, so there we go. I guess it all worked out in the end. Okay, so now we have multi-threaded. I mean, let's see if it works. I'm not sure if this is actually gonna make it go faster or worse. We'll see. I think that before we had about... Let's just see if we can build this at all right now. And I'm not sure if it's automatically single-threaded or multi-threaded. But I guess we'll find out. We get a crash. Interesting. Reached unreachable code. Oh, right. So main, we need to add a thing to the registry. There we go. It's like a dependency injection. It's pretty cool, actually. Oh, still crash. Okay. Entity, collision container. Collision container 284. So we have all intersections. Intersection with, I think this is like the entity ID or something like that. It will update the expected standard only, but you have to change some files yourself. Ah, I see. And it doesn't do any more commits after, right? Also interesting this as is that you have to squash all your changes at one commit because that's easier to work with. Right, yeah. Do you ever do any rebasing? Or is that how they kind of avoid it, so because of the squashing? Because I've never been in a project that has so many commits that it like becomes a problem with working together because of the Git history becomes an issue. Alright, I'll probably have to leave here soon. Let's see, I just wanna see if we can fix this real quick here. What could be going wrong here? So we're looping through the thing. We are calculating the offset. We're checking if we have passed the number of entries, then we break. If not, we calculate the end, which should be the minimum value. That seems correct. Then we, I mean, this could technically also be end there, it doesn't really matter. Then we spawn an async. And so we basically call this function with these arguments. I'm pretty sure end is, like if it's 0 to 0, that means it's empty. If it's 0 to 1, that means it has one element in it. And we make sure to wait for everything to finish, and then we look at all the intersections. We get the index that we have to then... Actually, this index... Yeah, this is the same as the... Wait. Yeah, okay, so this is wrong now. Right. So this is simply... This is simply I here. I mean, I don't think it matters because it never goes above anyway. But it should just be I. Yeah, we still get a crash. Seems to be the same thing. Container 284. Yeah. So we're trying to get the other entry, the other entity. Other entity. This is the entry that we're checking against. This is the entries that we get. I is the local index, J is the absolute index. Yeah. Yeah. Hang on. We're getting side effects in here. Okay. Yeah, that's the issue. I'm pretty sure. It's like we have this, so before we're kind of reusing like a buffer for every okay. Right. Okay, so what if we just pass a buffer instead? We pass a buffer that we can do. So we don't need to return. We simply use this buffer. But then we also need to pass it around here. where is that needed? If we let's remove this. Okay, let's see where this is used. Here we go. Well, actually, it's probably we probably want to have it be a dynamic list instead, because we don't know. I'm gonna say like result. Yeah, let's do that. Okay. You need a result. Right. Array list intersection k init buffer all intersections. Wait, no, this would be the intersections. There we go. And then we don't do this, we just pass, oops, that. And that should be it, because then it would modify the buffer itself. We don't actually need to pass anything else or do anything else there. Here we just return. Right, now you want the result, so let's just pass it along. Result unused. You want somewhere there should be like a result that's needed. here. Yeah. And now you need a result. You need a result. You also need a result. Wait. Yeah. Oops. There we go. All right. Anything else? You. Okay. Okay. So now yeah, I mean, okay, I guess this did it. Actually, no, this doesn't work. This issue here is like because this is not even created here. We actually need. No, this doesn't work. This does not work. What we need is we need to basically let's just do init or empty. And then this is like I is equal to intersections. Yeah. We can. I mean, what you could do is like init capacity. If you want to optimize it, there's not going to be as much like allocation calls. But let's just do like to on slice allocator. There we go. So we created dynamic list from empty, because otherwise this is not really initialized to anything. It's just we have this list, but we don't have these things are not initialized. We have to create those. So we create one here basically, and it's going to be allocated, well, appended inside here, populated in here, and then we grab the result from whatever we have here, copy it over, or I'm not sure if it's even copied. It's just moved here. Yeah. and then we should get the correct result in the end. So I think the problem before was that, yeah, we simply were using like a shared buffer across the threads, and that did not go well. So because every thread did whatever it wanted with that buffer. So let's now try again. Okay, it seems to work, although I don't think we got too much more. Oh wow. Oh. Oh yeah. Wait. Oh, I see. So actually, okay. These intersections. Yeah, we need to free them up here. Yeah. So basically, I mean, I guess we would do this. Allocator free intersections. There we go. Okay. Still takes a while to exit. Why is this the case? Search and replace. Update 405. All into. Oh, this one as well. Okay. Still getting used to this here. So there we go. There we go. Every frame, memory leak. Okay. Okay, there we go. Cool. Now, let's go back to our other project. We'll try to run this now, and we'll see oh, I see. So here we need what? Oh. Wait, this is in ZGE. Oh, because we never used those functions. Wait, no, this is in the physics collision container. Actually, this one is not. This one is this other one. So yeah, so we need to. Okay, well actually this is a lot easier now because we could pass this. I'm pretty sure. Instead of doing that. So there we go. let's do this. Either we return this if it's an R tray, or we do all this. There we go. And what's up with all this crap? Oh, it's the same thing over here. Okay. Intersected body. If this is the case, return. Otherwise, do all this. Same thing here, right? Okay, we kind of changed. So it's like we changed the algorithm here. Wait. Ah, this is different, right? Okay. Okay, but let's do that. Actually, let's do this. Right, so now this would be the same thing. And I would go through and we can reuse result. There we go. Intersecting line. Oh, that's the same thing. And this one doesn't have an intersecting line, so this would be like that, and then we simply return. Oh, we do this. Probably other errors as well. All right. Physics collision quadri line 601. Container on server 2. Result section entity to slash. Oh yeah. No. 646. What? Self-allocator start and page. What? Did we miss this? Why didn't you tell me? Oh, this is the intersecting line version. It's different, right? Well, okay. Come on, let's do it. Let's go. Let's go. There we go. Okay, why is the FPS so high? I was like, is profiling on? It seems to be. I'm confused. Then something feels very off here. I'm gonna save this trace. I forgot what it was now. I think this was left screen here. Save this trace. Because I'm pretty sure the FPS wasn't this high before. Even in the village. Let's see what happens if we go on the left hand side now. There we go. This is more like it. I think it has actually improved a little bit. Maybe. So let us... Well, okay. Why isn't this showing here? There. So I'll show you here. So this is how it looks like right now. I think it might have improved a little bit, but we are profiling, so let's go in here. We will discard this. I've saved this one, so let's discard, connect again, make it settle in this mode for a little bit, and then we stop. And let's see if we can... Oh, now we get all these things. Why didn't we get those before? Also, why are they like stopping at random points? Something feels very off with the profiling. Whoa, what happens? Oh, it crashed? I think it crashed. The profiling program crashed. Okay. We need to actually go in again then. Alright, I'll just go walking over here. Okay. And we'll go to the profiler, we'll connect. And let's just stop there. I don't want to take too much. I will exit the program. Okay, maybe there was a mistake. I don't know. I don't know if it collected all the data. This still looks a bit weird, but let's go over here, check one of these frames here. And wow, this looks different. This looks very different now. Holy crap. Look at this. Okay, I'm not sure if it's like properly... Yeah, it says main thread on all of these. It's only the intersection handler that's getting called. But yeah, and that happens afterwards. So I don't think... Yeah, okay. So we're essentially not zoning the inner threads here. So, okay, I see. Let's do that then. We have to go over here, and I should have seen this coming really, but whatever. So the thing is, should we do one for each one in here? I think so, yeah. So we'll have like a zone, some kind of zone in here. This one is like... do you have a zone? This thing doesn't have a zone. This has a zone. Populate and intersect. Populate has its own zone. This does not have its own zone. Maybe we'll add a zone here. So this would be like search and report in sections. Sure, why not? And this one, same thing except it's partial. Oops. All right. Let's try this again. And I mean, I have a few ideas where we could potentially save some frames here. Okay. So I'll go over here. I will, let's just discard this, reconnect, run a little bit, stop. There we go. We have all the information, so I'm gonna exit this just to, so we don't get any weird issues. Okay. Now, let's go into one of these frames. Check this out here. Okay, here's a physics update. Oh, wow, these are like red, very red here. I don't actually see... I see, this is only the main thread. How do we see more threads? Wow. Okay. Well, anyway, now how this is working is that beneath this part that we don't see, that is where all the intersection checks are happening, and then after that, this is essentially just compiling the results and maybe do some last checks, but then also just compiling the results into some kind of resulting list. We could maybe try to optimize that part, but I think this has generally lowered. Yeah, this it takes like 5 milliseconds now. I think it took like 10 before. So I think we've basically improved this by like 100%. What the hell? And I mean, if we go in here and we don't have seed tracing, and I'm gonna go over and open the chest to see how that looks. Okay, we basically capped FPS here. We don't get any higher than that, so there's not much to do in here. Now it's going a bit crazy on this screen here. Whoa. Oh shit, we got a crash here. Segfaults. Container 269. Well, that's not great. Okay. So that is essentially, that's like the basic intersection function for this. That is now not working properly. So I would assume like essentially anything that is going on in here is happening in one thread, right? So creating a thing here that is like changed in here wouldn't be an issue. And not anything, like nothing in here that we take from shared memory is going to change. But maybe just the act of reading it could potentially be an issue, maybe. Actually, I think I remember like Linux actually copies shared memory. So maybe it is, maybe it, I'm thinking about this, but then that would, how would that create a seg fault? It's just reading it. That shouldn't be an issue, I don't think. All right, yeah, so I don't know actually. It's also like this part, but this is also not, it's, I mean, it's shared if you take into account like where this is stored, I guess. But we're not messing around. Like each thread here will have its own section of this part, which will be local to them. So I don't think this will mess up anything either. Maybe maybe the allocator. Wait. How does that work? Sharing the allocator? I'll try to find something here. Yo Penguin, what's up? Async IO with IO U-ring. Zig thread sharing allocator. I mean, it's kind of not true. Like there is a default, like the GPA is like kind of like the default allocator. Or page allocator if you, that is already, like, it already exists. What about a thread safe allocator? Debug allocate. So it is actually threads. It's supposed to be thread safe. Okay. So this thing is called by the container. We're using the allocator we get from here, which is essentially the same allocator that is from the physics engine, which is we just get from here. Yeah, and that one is depending on the game. So if we go to like init, we'll say physics. Wait, where is this called? Oh, here. And this allocator is the allocator we have in here, which is where is that? Here. The hunt for, oh my god. Okay, it's essentially an arena. So is the arena is not thread safe or what? Wait, the allocator implementation provided is thread safe, given that child allocator is thread safe as well. Okay, I will trust you on that. So essentially, this allocator needs to be thread safe. And it's just a GPA. A default selected general purpose allocator for temporary heap allocations, thread safe. So, okay, so according to Zig, it should be thread safe. Right. But there's some something not going on, not correct here. So it worked pretty well until we hit something. It seemed that seemed to have triggered the issue. Let's try this again. I don't understand why this is not like showing up. There we go. So it works there. Getting hits works, but doing that doesn't work. So that actually, so that spawns a new thing. It spawns like the particles there. But I'm kind of confused as to why that would crash. But yeah. Search intersections, page by page, check collisions. Yeah, that's it. It seems to be the initial as well, so that makes sense. It crashes like immediately for some reason. Is it something to do here? Second here. Okay, so the allocator is probably not the issue. What we could do as well is, like, for the allocator, we initialize capacity here for these intersections. Actually, we could We could probably just initialize one time here. So we'll get like intersections. Whatever. So this would be allocator allocate intersection k, and this would be like entries length times the number of like total entries, really. So that is all the potential intersections that we could get, really, here. Now an intersection is, I don't think it has that much. This is like a U, let's say it's 128 or something, I don't know, just to give a high ceiling. Then we have like F32 and then 2 F32s. So that's like 332 plus 128. Yeah, so it's not really like a huge amount of data. So that's fine. Even if we have like a lot of entries, that should be pretty tame. So that is our intersection list. Actually, this is what we want. There we go. Okay, so the idea is that I want to kind of have like pre-allocate all the potential intersections that we could have, and then this, now we can do init buffer, and we can say that this would be many intersections, and this would be like I times entries, no, entries times length. Yeah, that is essentially the buffer that we have. Buffer offset buffer end is buffer offset plus this, and then the buffer is going to be many intersections, buffer offset to buffer end, and that is what we pass in here. There we go. Now, we don't really need to do toOwnSlice. What we do is we can say, well, actually, we cannot do one to, because if we're gonna be able to free this up, we have to do some copying, actually. So what if you run this? If you run this on a buffer, what happens then? Like if it's initialized with a buffer. So we do toOwnSlice. I mean, I guess that works. They kind of should copy it then, right? Maybe. Remap. Oh yeah. Now that should work, right? Wait, no, it doesn't, because there's no allocation. So this shouldn't work. So it should go over here and make, like, copy it. Yeah. Okay, cool. So essentially, at the end of this would be like sort of empty. So we can do then allocator free many intersections. Right. And then, like, in here we could essentially, instead of using append, we could use append assume capacity, and that would kind of it would like improve a little bit, I guess, the performance, but whatever. Now we like pre-allocate all potential intersections. So that is probably a little tiny bit faster because we don't need to like reallocate in here a bunch of times if we get a whole bunch of intersections. Although, if we don't get any intersections for a lot of things, this will actually decrease performance, because then we actually do an allocation instead of not doing an allocation. Okay, well, whatever. Let's build this. Oh, we got a crash now immediately instead. Interesting. 271. What? Seems to be the first thing, because we call populate. Get an issue here. Wait, this doesn't make sense because this isn't even called. Wait, collision no, it's container. Sorry. 271. There we go. Here's okay. So it's the same place. It's just that it happens earlier now. All right. So there might be something bad with how this was done here now. So let's check that. Maybe we should just pre-allocate this whole thing. No, that won't work. I mean, yeah, the allocator should be thread safe, so we just have to trust that. I mean, we could pre-allocate and just provide like the pre-allocated thing, but then it's like, okay, well, what do we, how can we return something then? Many intersections. So essentially, if you have 100 entries, you would end up with, in total, with all the threads, 100 squared. You would end up with entry squared intersection, potential intersections. Right. We free this up. This should like move it to somewhere else, so it shouldn't be an issue freeing it after we're done. This is then populated with the moved stuff. It's just used as a buffer here. This is just a buffer and then we move it. That should be fine. Should be fine. Alright. I'm not sure what's going on. And maybe I'll have to find like a different way to approach this issue. Because I don't even know kind of how to... I would need to think about like how to approach this problem. Like how to debug this here. Yeah, I think I'll deal with this tomorrow. I need to take like new breaths or whatever you say. Yeah, maybe sleep on it a little bit. Maybe we'll figure it out tomorrow. But yeah, that's gonna be it for this time. So thank you very much for joining me here. It's nice getting back into this game and continue on it and improving on the game engine as well. Feels very nice to actually get multi-threading in. That's a first. We'll see if it holds up here though. I might have to walk back on that, but yeah, we'll see. We'll try to make it work, and yeah. But yeah, thank you very much for joining me, and